video. This is regarding EC542 neural networks final project recording. We are team 173. Our topic is traffic sign detection using Yolo V8. The motivation that led us to build this project is a devastating news, actually. So lately, there have been a lot of road accidents. Almost like 1.19 million people die each year because of road crashes. And recently, there have been even more devastating news on how young or old age people die due to accidents and due to negligence of driver, especially. So all those things led us to build a traffic sign detection system with a high accuracy and high confidence rate. So here comes our system. So our system not only just is because of those motivations, but also it motivates us to do very good traffic management, regulation enforcement, and it also prevents and accidents and also help in like improving the driver experience when he's driving, giving him an assistance of what are the signs that are about to see and all the stuff. So we our project can also be embedded into enhance autonomous driving. So if we have a very good accurate prediction, it could actually help in driving the autonomous vehicles. And obviously, if we follow rules and if everyone's on a proper way, we would obviously have an environmental impact of fuel efficiency and transportation sustainability as well. So here comes a problem statement. So it is automated traffic sign detection system. So as a baseline model, we used CNN. We got an accuracy of 96%, which is like very great for a baseline model. But here comes a Yolo V8, which is a state-of-art object detection algorithm. Obviously, easily went through the baseline algorithm accuracy to almost like 98%. So so the sources of our data sets were from different research papers, RoboFlow, and Kaggle as well. So we got around like 12,000 images, out of which we used almost 7,000 for training, 2,000 for validation, and the rest for testing. So the challenges that we gave our model through our dataset was we made sure that we included images in bad weather conditions, good weather conditions, high light, low light. Also, we made sure that the images had proper potholes of similar shapes of the traffic signs. So we made sure that we had all those images. And for the pre-processing, we made sure that all the images are of uniform size, that is 416 cross 416 pixels with 3 channels. And we had, since we collected all these databases, I mean, like data sources, we had to augment data. Some of the classes had very few images, so we had to augment those data. And so normalize, yeah, we did normalize the arrays to 0 to 1, so to make it easier for the models to predict. We made the train test split. We visualize some random samples. As you can see here, we have images from different backgrounds, different lighting, and different countries as well. We actually use data sets from German and also US. So here is the histogram label of distribution. So as you can see, this was before the data augmentation. We had a very little amount of images for speed limit and high images for red light and green light. We didn't want our model to be underfit or overfitted by these, so we made sure that the class distribution was equal by data augmentation. And here comes convolutional neural network. This was our baseline model. As anyone would go for object detection is CNN, so you and we went for CNN. And here is our model. We built a sequential model with almost 4 convolutional layers, ranging from 16 to 128 filters. We also applied max pooling, batch normalization, flatten in between in order to make the data normalized and all this stuff. And we made sure we used ReLU activation methods. And we also used a dropout higher ratio, cumulative to 0.5 to prevent overfitting. So we used Adam optimizer and also categorical cross entropy loss function in order to use multi-class classification. So our metrics for CNN was accuracy. So we got almost 96.96 accuracy on the test data set. So, but in comparison with YOLO, it did little bad compared to YOLO, but YOLO was obviously being the state-of-art algorithm got us more. So here are some results. So the left image to the is the confusion matrix, and the right side is the bar graph representing how our model accuracy, loss, and val went across the epochs. Here comes our next model, which is YOLO V8. This is an advanced object detection algorithm. So it stands for its acronym, you only look once. So these algorithms are like heavily trained on for object recognition. So we use he tried so surprisingly we even reduced the images a little bit. So we tried different configurations, different layers, and we just wanted to try how our YOLO model would perform even with lesser number of data. So we brought it down to 4,000 and we trained it for just three epochs, but that went really amazing. So we got very good accuracy, and here is an the module, like the architecture of a YOLO V8 that we used. So here is the class-wise validation results, and the right image is very surprising for us. Like the precision rate for the first epoch was itself around 93%, which was very great for us. And yeah, here is the precision confidence curve. As you can see, when the precision almost reaches 98%, our confidence rate is almost one. So it is a very good precision confidence ratio. And here are our final results. As you can see, the CNN model gave us a 96.96% accuracy on test, and our YOLO gave us 98.37% accuracy on test set. And that's all pretty much. Thank you so much for this opportunity.